Hello my dear students, the first lecture of the radio receivers. The primitive type of receiver is tuned radio frequency receiver. In this discussion we know about some primitive receiver to modern receivers of radio engineering. So first of all, here you can see that is the tuned radio frequency receiver before Second World War. Most radio receivers were the TRF type, and here you can see they are the blocks that tells the story that they have some amplifier stages. As you can see that the first RF amplifier, second RF amplifier, these are the amplifier stages. Through amplifier stages to detector. That means we have to amplify the signal quite a bit, quite time by time. So we need a stage by stage amplifier. That kind of receiver, sections. But there you can see there is ganged. Ganged means there's a gang capacitor that has been connected from decoder to the radio frequency amplifier, stages of amplifiers. And after the detector detects the signal, that it puts the signal to the audio amplifier section, and then after power amplifier we can get the amplified output from that. That is the TRF, it's tuned radio frequency receiver. So in this kind of receivers are known as tuned because there are in these amplifier stages and detector there is some RC components that's been used here, ganged capacitor inductance. So these are the tank circuit or tuned radio circuits. So these, for this kind of a thing, that is this kind of these kind of receivers are known as tuned radio frequency. Now we are heading back to the next section of the tuned radio frequency receiver. TRF receiver users that is simply designed and aligned to broadcast frequencies between 535 to 1640 kilohertz, but the presented difficulties at high frequencies, instability, insufficient adjacent frequency rejections, bandwidth variation. So these three type of things are quite important in the tuned radio frequency receiver. So there are three type of thing that has been the key feature of the tuned radio frequency. That is there is a drawbacks, I would say. There is the instability of the signals. So you have to tune the gang capacitors time by time, and insufficient adjacent frequency rejection. So that has been reluctant to frequency rejection process, and also there is bandwidth variation. So these kind of things are the drawbacks of the tuned radio frequency, and you have to know that is a broadcast radio receivers. And solution of this tuned radio frequency is the modernized version, that is super heterodyne receiver, that I will tell you broadly after the part 1 lecture. So here you can see the super heterodyne receiver. This is the basic block diagram of the super heterodyne receiver that you can see here. That there is a gang tuning too in the local oscillator mixer RF stage. But what does the super heterodyne receiver really differentiates with the tuned radio frequency or TRF receivers or amplifier receivers? The thing is that there is an RF stage, but in previous receiver sections that has not been like that. That has been the first stage, second stage, a lot of the stages are there that's been ganged to each other. That's the RF amplifier stages. But here we can see there is just an RF stage, radio frequency stage, single stage, and from this we get the frequency that has been the frequency of the RF stage, and after that there is an FO frequency, FO, that you can see here. So in the RF stage we get the signal frequency Fs that has been gone through to the mixer side, and mixer means mixing out of the two type of frequency components. First of all, there is a local oscillator downwards. You can see there are ganged tuning between the three parts of the RF stage, mixer stage, and local oscillator stage, and that is the ganged tuning, known as the gang tuning. The tuning is quite similar to the previous one, but the difference is that as we have read earlier in the communication and the modulation parts that there are some high frequencies that will mix in towards the modulation sections. But here we can see that there is a local oscillator. Local oscillator means oscillator is the frequency generator circuit, and they generate the FO, operating frequency, of higher frequency level, and these two frequencies now mix together and go through to the next level, that is the IF amplifier. But the here in the mixer that we have seen that the difference frequency came here in the form of FO minus FS, that we know that this FO, the operating frequency or oscillator frequency, is quite higher than the signal frequency. So this oscillator frequency FO and minus FS, that means the difference between these two will go to the intermediate frequency amplifier. What does it mean, the intermediate frequency? As you know, as you have passed the intermediate studies of your life, when did you pass from the SSC to the HSC, higher secondary, and then got on to the university or college or any other higher education institutions? But we have to pass a very small stage that is known as the intermediate. That means that is the bridge between the two parts of the secondary education to the higher education. So there is the bridge between these two, is known as the intermediate. So intermediate means the time that has been remaining, or that has been in the middle of something. That means if it is FO minus FS, so there is a bunch of frequency or frequency selection that has been very limited frequency between these two that can be operated. And the IF amplifier means this frequency has been amplified now, and after the amplification it will go to the detector section, and the detector section rejects this and send it to the audio and power amplifier section. After that we will get the output out of the speaker side. So my dear students, you are now really understand that there is a difference between the two frequencies that we have seen here in the IF amplifier and the mixer section, intermediate sections. That means the entering section between the oscillator frequency and the signal frequency. So the name came from that point of view, that heterodyne. Hetero means the difference between the two frequencies. Difference, it's the Greek word, it means difference. So the difference between the two frequencies are the main what can I say, the key feature of the main feature of this receiver than the previous one we have taught as that the TRF sections. And the thing is that you can see here that the IF amplifier and detector section and the RF stage section has been connected to AGC section, that means automatic gain control. Why that automatic gain control is situated here? Because it should have to be controlled gain. That means our desired gain should have to be always onto the cards. Why that has been said here? Because if you go through to the previous section, that is the insufficient adjacent frequency rejection. So this rejection will go through to the FO minus FS section, and the bandwidth variation will be and the instability also. These two things will be eradicated by the help of automatic gain control. That is means that there is a certain gain that the signal that we should get, that we have a certain type of signal that is our desired signal, what can I say, that means amplification is needed. In that section AGC controls this and do the same thing again. And for this thing, that the AGC is related to the power, that means the heterodyne means the difference between the powers. So dyne means power and so hetero means the difference. So the super heterodyne receiver is the perfect combination to remove some problems, to eradicate some problems that has been created in the TRF sections. Thank you very much for being in the part 1 section.